Hope you guys are well fed by now. So if anybody has thought about the answer for this question, please raise your hand and I can give at least one person a chance. There we go. No, I'm coming to you, yeah.
I don't know if any of you have heard of the YouTube channel Kit Boga. They waste telehealth scammers' time. They pretend to be like old people, senile people, the typical victims, and they just waste the scammer's time. And at the very end, the scammer's about to get the money. They accidentally transfer it back to their own account. And the scammer usually screams at them, swears at them, says they're a dumb old person. So what I was thinking, we could use generative AI to, whenever you get one of these scam calls, just automatically waste their time at scale. And you could build all these services and servers, and just whenever you find out about one of these scammers, plug the number in, and then it calls them as like, one after the other, old person after old person after old person. They never get the money. Sorry, that was my idea.
Hey man, that was pretty cool. Anyone else? Anybody else? No? Okay, all right. So let's get started. Some of you might know who I am, but my name is Sonam. I am your host today from AI Camp, along with my team members here, Hamza and Jive. Welcome again. For the new ones, I know there are many first-timers today, and I'm so glad that you guys are here, and your curiosity led you to find out about AI Camp and attend the event. The QR code that you see on the screen, if you scan that and then comment, it will take you to a LinkedIn post. All you have to do is comment on it, and then towards the end of the event, I'm going to run a raffle where I will announce 2 winners from the lucky draw, and each of the winners will get a $25 Amazon gift card. So yeah, I'm gonna give you a few seconds to scan. 3, 2, 1, go. So who we are, AI Camp, basically it's a global AI developer community, and we are spread over in 150 plus countries, and all the pins that you see on the map, some of them are probably missing, but we are really there. I mean, yeah, no kidding. We have local community chapters in major cities. And the goal of the community is to foster the curious people in AI and then bring the community together through various different ways. So to get involved, well, there are several ways that you can get involved with us. You can join our community. You can submit talks if you want to give a talk, submit topics to give a talk, just like this event. And you can sponsor these events for food. We have good pizzas today, thanks to our sponsors. Maybe next time, if we get more sponsors, we can get some beverages, maybe alcohol. And yeah, and you can collaborate with us on various different events. And if you want to do either of these, the best way to reach us is by sending an email at info@aicamp.ai. I repeat, info@aicamp.ai. So as much as we want to build a community, we do it by educating and bringing all cool resources from where you can learn. And every Friday, we have a virtual seminar. And then we have been doing 2 events per month. Like one of this is here, there where you are. The next one is on May 1st. Again, same venue. Keep an eye on the AI Camp website for more details and more up-to-date details. And we do a hands-on AI workshop and boot camps. And guess what? The next one, the one that we are very excited about, is the AI hackathon coming on April 27th at Cloudflare's headquarters, which I think it's in the same area. I could be wrong. So these are some more details about the hackathon that's coming up. Please scan the QR code to find out more details, and if you want to participate, if you have any cool ideas, if you want to sponsor it, and anything else. And Google is sponsoring, and yeah, so once you scan the code, you will find more details about it. Huge thanks to all our clients and sponsors. This is a beautiful slide, which I sincerely appreciate. I hope more companies join us and I can put those logos on this slide. I want to do a quick community shout out. If you are hiring for full-time, part-time, intern, contract, whatever, or if you're looking for a new job, a new opportunity, looking for co-founders or project collaboration, or want to host events, I'm going to give you 30 seconds, the lucky 3 or lucky 4 people who can shout out. Please raise your hands and I can pass the mic.
Hi, everyone. My name is Tim. I'm new here, new to the area, actually from Colorado. I am a recent PhD grad and I'm looking for work.
Congratulations.
Thank you. Yeah, machine learning, research, or engineering. So thank you.
Thank you, Tim. Anyone else? Hamza, right behind you.
Hi, my name is Shubham. I'm from Asana. My team is looking for enterprise data and intelligence EDI manager, like a data engineering manager. So yeah, if anywhere has a close to 8 to 10 years of data engineering manager experience, please reach out to me.
Thank you. Anyone else? There you go.
Hi, everyone. My name is Skylar. I just dropped out of college a couple weeks ago, so it's fun to be here.
Good.
And thank you. And I'm interested in neurotech, so if anyone else is interested, let's talk. Yeah.
Thank you, Skylar.
Hey, everyone. I'm not an AI person, but I'm Ken, Director of Developer Experience at Reddit. And we have one position open on one of our teams for development environments. So if you're interested in like Kubernetes and have experience working inside of developer tools or development environments, please come talk to me.
One last chance. One more. Anyone else? Last call. Ah, there you go.
Hey, my name is John. I am building an AI bot to help parents, and I'm actually looking to talk to some folks who are parents and who maybe feel overwhelmed with all the stuff that they have to deal with their kids. Not hiring yet, but I am looking for a co-founder, so come chat with me.
Thank you. All right, moving forward. Please, if you scan these QR codes, it will take you to our Slack community and Discord community. We are pretty active there, so if you have any questions or if you missed anything from today's event, please reach out to us on Slack or Discord. Huge thanks to our sponsors for today, which is the GitHub for this beautiful office as always, Weaviate and Zilliz. And all right, so this is it. And let's start for our today's event. Our first speaker is Fei Zhang from Pinterest, who is going to talk about image contextual understanding via LLMs. Welcome, Fei.
Big applause.
I'm gonna move my. So you can use this mic or you can use this one too. Okay. Yes. All right. Sorry, can I get a help here? How can I maximize that?
All right. Hi, everyone. My name's Faye. I'm a senior software engineer at Pinterest, specializing in data, ML, and now Gen AI. So today I'll be talking about the multimodal contextual understanding and specifically share some of my learnings throughout the long journey of training a multimodal model. And by training here, I mean a full training, not a parameter fine-tuning, etc. So as Logan from Google AI last year has predicted, 2024 is the year of multimodal models. In fact, some of the researchers, engineers, and founders have also predicted that in 2 years, all the LLM will be multimodal. So in order to better understand the concept of this, let's look through some quick examples. I was able to get Gemini 1.5 Pro in early access, but this is an example that others have done online for video to code generation, where you pass in a video of screen recording of a website to for recommended books, and the ask a model to generate a full stack code for web development to represent this, whatever the video has shown. So surprisingly, but not surprisingly, the code is actually runnable and compilable. One fascinating thing I found was during the database layer for the data that the model generated, it also captured the author and all other context of the books, which was in the glimpse of the video. But it was really cool that the model was able to capture that. Another example would be context understanding / reasoning. This is done via GPT-4V, where you pass it a super incredibly confusing parking instruction, even for humans, and ask, today is Wednesday, 4 p.m., can I park here? So what the model does is it started to analyze each of the parking sign. No parking 11 to 2 for Tuesday, no parking 3 o'clock for road cleaning, and come to the conclusion that today you're able to park for 1 hour only as of now. It's funny because back in college, this is the exact example that my UI professor has taught was the worst design for human. I know that decades has passed that our municipal department is not able to fix this for us users and drivers, but AI can. So we're very thankful here. So to summarize, multimodal comes with 3 attribution. First is input and output can have different modalities, text to image, image to text. And secondly, inputs can be multimodal, image, text, audio, and similarly, same for the output as well. Now, let me share my journey of training a multimodal model. So it's a mouthful here. It's a complex process, but I try my best to summarize in 4 stages: architecture, data, training, and evaluation. So for the architecture piece, you essentially need to understand your use case. Probably start with something, pick your backbone architecture. For example, it could be transformer-based, it could be linear sequence-based. And when it comes to integrate multimodalities, you need to know what's your input types. Essentially, you want to bind all your input into one single space. And the downstream application factors, including search, generalization, classification. So you need to make sure your architecture can satisfy your needs here. So once you have designed your system, you need a data. Luckily, there are tons of data out there these days, open sourced, like Common Crawl, Coco, and also paid version. But what you need to essentially, including data collection and processing, you also need to resize, normalize, and do other feature extraction. I will talk about some of the challenges I met in the later stages. The third step is training. So You essentially need to pick a foundation model to suit your needs to train on your multimodal data sets. This could be Llama, Mistrals, trained on JAX or via PyTorch system. And very likely you will need fine tuning. This includes transfer learning or reinforced learning from human or even AI. And very lastly, evaluation. So this is where you use metrics to evaluate the accuracy, precision, sometimes recall. Because it's a multimodal use case, likely you need to calculate the contribution of each model. So before I dive into the model architecture piece, I wanted to give shout out to these 3 research papers. So number 1 is the classic Flamingo, where I'm sure most of you guys know. It's a piece to detail how to train a visual language model in few shots learning. And the second one is learning transferable visual models from OpenAI back in 2021. This is essentially the clip model I will be diving into just shortly. And lastly, is the transformers. This is where we use a vision transformer to combine our models and to do our iterations, training, and with the expert and use of attention. Now, let's talk about the clip model. So this was invented, I think, back in 2021. It was the first large-scale AI model that takes 2 modalities, image and text. What's so special about this piece is it essentially used the pre-trained image and text encoding for an association. So what you see here is this is an example where you pass in a Aussie puppy named Pepper. And that gets encoded through the metrics, and same with the image as well. And as a second step, you can use this learned text encoder to create a zero-shot learning. So when user send in an image of a dog, you can quickly decode that image and have the prediction from the previous learning of output. This is an image of the dog. For full transparency, I've also evaluated Vertex AI. This is a Google embedding, does similar things. Both models performed exceptionally well on the 100K and animal classification examples I provided. But the one thing that Clip stands out for me was the score stratification. So essentially, it was easier for Clip for me to read when there's a strong breaking point score on differentiate relevant and irrelevant. And that is why I stick with this model. Moving on to 2023, so Meta came with the image bind, the one embedding space to bind them all. This is built upon on Clip, doing very similar things, but to combine across 6 modalities: image, text, audio, depth, thermal, and IMU. IMU stands for the measurement to predict the movement of an object in a gravity force or velocity. So if you wanted to use your embedding models for anything other than image and text, image bind is a really good industry benchmark that you can refer to. I know it's usually confusing for people to read a research paper and then try to implement the loss function. So I'm going to share quickly my trick to how to understand and implement this in your production. So let's debunk this loss function. On top is the original loss function for image bind. The goal is to understand this better. I first stripped away the variable of tau, so you get marked away in the red pen. Tau is a learnable parameter for temperature. It's kind of not as important here, so that's why it helps to understand by taking that away. And that gives us this second line without tau. Because the purpose of a loss function is always to reduce the loss value and loss, let's look at the overall structure. It's a negative log function, so naturally I wanted to plot out what that looks like. given we want it as low of the y value as possible, what that means is you need to increase the value of x. So what that means here is you want to increase the numerator and decrease the denominator as much as possible. And I'm almost there, promise. So on the numerator side, this is an exponential function. It's actually really simple if you look at the circled value here. It's a dot product of Q, which is image modality, and with K, which stands for other modalities. This is a measurement of how similar of two modalities is. What that means is it only wants the positive values of the image and other modalities together at the index of I. And on the numerator side, it's actually the quite opposite. It wants the negative pair of the two. So to summarize, what this all means is this loss function represents the close cases, or they want the close cases of where image modality and other modality at the index of I create a similar space. They want those cases as close as possible. And on the contrast part, they want the negative experience, AKA irrelevance, as far as possible for the training purpose. See, pretty easy, right? Now let's dive into the transformer space. So the transformer of my choice this time is a soft MOE, stands for mixture of expert. So this is an improvement from the traditional mixture of expert, because we know that MOE technically performs really well when you increase your models without having to increase the cost of training and inference. But it also brings the downsides, which is the training instability and also the difficulty of scale up your experts. So there comes soft MOE. It's a fully differentiable sparse transformer. As a first step, it computes the logits, which it means the score of the token of a slots using a dispatched weights in a linear combination. And as a second step, it also normalized the weights that's presented in the green and blue box over there. And third part is, I guess the most important part is it feeds each slots into the expert. So in this diagram, each expert is assigned with 2 slots, but that's the choice of the designer. You can optimize this however you like. And very lastly, it outputs the tokens in the linear combination in the row form over there. I know back in 2023, I think the Mamba paper came out where everyone freaked out. We all need to train the sequential model now. Let's ditch transformers. But Google just came out and demonstrated how you can scale up billions tokens of your model by simply scale up your transformers. So this is a good example of that. Now let's talk about the fun part. So there are a few interesting contextual understanding challenges I wanted to share. Because I come from the NLP background, we know that text training and understanding can get you pretty far, but a lot of time it can only get you so far. So the hateful memes challenge is one example where the text here is incredibly positive, but when you combine with image, it can be negative. So what that means is in a classic machine learning tactic, it's hard to kind of capture the content essence without the vision. So that's what the hateful meme was created by Meta, I think back in 2020. It is actually also a competition and open source data to design and measure the progress of multimodal vision and language classification. So they come up with the benchmark and also the model iteration. So in unimodal section, as you can see, where it's a pure BERT text model based, they have the very low score around 50. And ACC kind of measures the classification performance of if the model can get it right, positive or negative. And ROC stands for under the curve. So this is a metrics to consider a true positive with a false positive in combined. So in the mid-fuse section, you see that Meta has tried to combine few unimodal pre-training with a multimodal. The one stands out is the concat BERT. I believe this was a BERT model trained on top of ResNet 152, was able to achieve a slightly higher score than unimodal section. And obviously the winners are the multimodal pre-trained section with visual BERT Coco. Coco is a data set, open source data set provided by Microsoft. These at that time was very state of art, self-supervised model and able to provide a really high test score that is almost close to human, but not quite. Remember, this was a challenge. So in Europe 2020, in the conference, this was actually was the official challenge of the years. And the winner who used the enhanced multimodal with external labels and in-domain pre-training was able to achieve an 85.44 score. That is pretty much reach the human level. Very, very incredible. What he does really cool was, besides the cool multimodal training and reconnecting classifications, it also pre-trained a few domains with people with different race types. So I think having an edge in your training data helped you push to the next level. And the winner also that year also took home 100 grand from this challenge. Another fun one is visio-linguistic compositionality. So this means a novel task data sets for evaluates the quality of vision and language model to conduct the composition reasoning. As shown in the photos here, these are two pictures with two choices of captions that you need to match. First is some plants surrounding a light bulb. And the second is a light bulb surrounding the plants. It's interesting because all the captions are actually using the exact same words, but just in a different order. So this is very tricky sometimes for a human to understand as well. Now, lastly, let's talk about the overall benchmark. Because the multimodal training process is still very much growing in the stage process. I found this one, MME, published last year by Tencent, was incredibly helpful from my learning experience. It combines both perception and cognition, including the 4 subtasks. For perception, there are a few examples, including color, asking if the skier in the Dolomites there is wearing a red jacket or yellow jacket. For perception, it tests the OCR. Is the number on this logo the below? And for cognition, I think because it is from Tencent, it actually uses a few Chinese labels. Is it appropriate to translate these terms into classic taste? And finally, let's talk about the use case. So what did I do with the model in the real world? I was able to build a multimodal search with RAG. I know there are 2 other speakers later will touch on RAG, so I won't go super in depth on this. So essentially, if you think about it, search these days have definitely moved from semantics to contextual understanding. When a user search casual chic outfit ideas with this bag, you need to first understand what is this bag. So in this case, I was able to build the catalog, a shopping catalog from the Row website into a vector database, essentially capture in the encoding set, capture my multimodal corpus with a backbone encoder, and then send it into the dense index. The search engine then have to understand what is a casual chic outfit ideas. It might be something really flowy, streetwear, and etc. So as a result, these are the examples that come out with the women's fashion inspiration carrying this piece, the Row Margot bags that is very hot right now, according to Vogue. As the last slide, I wanted to talk about the future trends I'm particularly excited about. Number one is synthetic data. So as we know, DALL-E 3 is actually created 95% based on synthetic captions in their release study notes from DALL-E 2. As you can see, the higher the training steps is, the synthetic data model tends to perform much better in the yellow line here. Another example is the Liang Coco, where was trained on Liang based on a simple blip caption of Liang old data sets, but also able to bring out the creativity of Liang Coco because the image caption is just so straightforward and get the model to go on the right trajectory. And the last one is a mixture of attention for subject context disentanglement. This is a research paper published by Snapchat last week. I have yet to test in production, but I'm very excited. This is because mixture of attention is actually another format of mixture of expert, which is the model I explained earlier. But with a bit of tweak, you're able to control the personalization with the context much better. Because imagine when you pass in different photos of people and then wanted to ask for the same context image, a lot of times the ocean color would change, the tone and the clothing people will wear would be different unless you perform a strict template. But this model does not require any of that, but able to generate very decent results. So I think that wraps up all the talks I have today.
Thank
you very
you.
much.
Thank you so much, Faye, for this excellent presentation. Thank you so much. We have time for some questions if you want to ask her for some questions.
That's okay.
Hi, yeah, so great presentation. I just wanted to ask, what do you think that synthetic data is already running into some sort of, I guess, constraint, like where we're not able to go, we're not able to get better accuracy, better metrics using synthetic data? Do you feel like the bias has something to do with the kinds of models that are being trained? Like, I guess, what's your take on that and everything you've done? Yeah.
Yeah, so I think synthetic data is very much in an untapped market right now. It's mainly done by the large company who has a huge research center and able to clean data and for better distribution, as you say. But for people, individual players, I think it's hard to achieve that data sanitization via pipeline and to scale the token as you need. I know that it's always a secret technically for multimodal of what we train on, and it's kind of hard to bring that bottleneck. So I know Hugging Face is trying to maybe release something in multimodal space, but I'm hopeful.
All right, do we have another?
Yeah, I was wondering about with Clip, you have all of the visual tokens that it makes, and there's 257. Is that last one that's the image token that's actually contrastively trained with the text token, the class token? But the rest of the tokens are not really part of the loss. Then you had Philip, which was actually trained more fine-grained, all the rest of the tokens, but I guess because that's closed source and Clip was open, then all of the LMMs that we have are based on Clip instead. But do you think that doing the fine-grained training where you have all the rest of those visual tokens are actually aligned to the semantic content of the image, would that catch on in the future, or do you think Clip is here to stay?
Ooh, good question. I think Clip as a foundational piece back in 2021 has influenced a lot of the future models that come earlier, like there's clip now or fusion clips. Those are utilizing the full tokens. I think some of the steps, as you mentioned, I have yet to explore them all, but I know that some people have gotten really good results from that as well.
Awesome. Thank you.
Yeah.
Anybody else? All right. I think we're good. Thank you so much.
Great.
Please
Thanks
give
for
her
having
another
me.
applause. Thank you. Our next speaker is with Adam from Weaviate. Please give him a big applause.
I was going to speak into this. This talk is actually an ASMR session. Okay, I'm going to record this talk because I want to, this is the first time I'm giving this talk and I want to see what sucks about it later. So I'm going to record this and I think, all right, this talk is recording now and so I'm going to jump over into presenter view and grab these notes. That's not what I want. Okay, let's see. I guess the last thing I need to do is actually switch onto my phone Wi-Fi. Oh, I don't want the, I had some issues with it last time. Thank you, Sonam. Let's make sure that my internet's actually working. All right, I'm in. Okay, how's everyone doing today? Good? Okay, good. Cool. So I like to start off every talk with some shout outs and some gratitude. So I'll start off today with 3 things I'm thankful for. I'm extremely thankful for the folks at AI Camp for hosting this event and bringing this community together. So huge thank you to Sonam and Hamza and the team. I'm also really thankful to GitHub for hosting this space and bringing all the people and having a space to bring all people together. I'm also really thankful for GitHub because they let me host an event here in GitHub every month called Hack Night at GitHub. And I'm pretty stoked about this. If you're interested in getting involved and hacking, I have an event on May 14 where we're bringing together a few different companies. So Weaviate will be there, OctoML, 12 Labs, and Strata. And so if you want to get in, I'll show this slide again at the end, but here's an opportunity to get onto the Luma now.
I definitely encourage attending this event. It's going to be fun.
Who was at the March 26th event? If anyone was here.
Me.
You were here, yeah. Did you have a good time?
Oh, fun.
Awesome.
A lot of fun.
So I'm really excited to bring this back, and we're going to do this one on May 14th. It'd be great to have all of you there. And lastly, I want to say thank you to all of you for taking time out of your week and your busy schedules to make this happen and coming out from Sacramento. So thanks for coming around and making today just a fun-filled event. I just got 4 registrations on this. I won't accept right now, but I'll do it at the end of the event, I promise. Okay, before I start, I'm gonna grab a quick selfie if that's okay. Say cheese. Nice. Okay. So I really want to get to know you a little bit better before I get started. Raise your hand if you, let's get to know each other better. So raise your hand if you're in sales. Anyone in sales here today? Oh, I see 1. I see 2. Nice. I really like the whole org of sales because I think it's very underappreciated. It actually drives a lot of really important aspects for businesses, and I think it's a very important function. Any product people in the room? Super cool. It's good to have you here. I also really think that product is a critical role for success. But without developers, am I right? Without developers, where are my developers at? Developers are a really important part of this as well. And I think the message I want to bring together is this ship wouldn't be a ship without all the parties at play. And so it's good to have a community where all of us are kind of present here. Okay, and let's see. Who knows what a vector database is? Okay, maybe I'll ask the other way around. Who doesn't know what a vector database is? Okay, there's a few. That's okay. This is for those who are new to the idea. Vector databases are a type of database that stores these things called vector embeddings. And vector embeddings are a numerical representation of data that encodes semantic meaning in this vector. And if you graph out these vectors in space, you'll find that this is incredibly challenging because oftentimes these vectors are in high dimensionality. So it could be as high as 1,500 dimensions. And we don't have a way to visualize more than 3 at the moment. So we encode semantic meaning through vector embedding models to produce these embeddings. And we can pass in whatever data we want. We can pass in text data, unstructured data, structured JSON, images, sound, and then you can do cross-modality search across them, which is what Fate was talking about just moments ago. That was really exciting to hear and to learn about. But that's what a vector database is. It's a database that stores embeddings, vector embeddings, and they allow you to do very intricate search over it. And who's heard of Weaviate before? Okay, cool. I have some Weaviate socks. Anybody want some? I'll take the first 2 hands. See right at the front. One for you, one for you. Nice. Okay. So I'm limited on time. I have a lot to talk about. I'm just going to go through a thing about me. My name's Adam. I'm a developer relations engineer at Weaviate, and I really like to tinker. Was anyone at the last AI camp where I spoke? I think, John, you were. Anyone else? Or is this a fully new crowd? Some of you were too, and Tom's too. What I did last time was I brought you into my house. We did a thing where we jumped into my 3D printer and we started, I actually started a print here today, or last time. I'm gonna do the same thing again, but I won't be able to go back to it to finish because I think the print that I'm gonna start today is a little longer. And I wanna print something called a GitHub Skyline because GitHub Skylines are awesome. Are you all familiar with GitHub Skylines? No, okay. Who has a very active GitHub account and wants a 3D print of their, who has a very active GitHub account? Cool. What's your handle? 1 second. Did I hear nacho? Yeah. Like that. Ferra, F-E-R-R-I 1894. No, it's I. Oh, A, here. Cool, thank you. So let's search. Let's see how active your GitHub account really is. So GitHub will take your heat map and then generate a skyline over it. And if everything works, we should see something come to screen. Nice, okay, here it goes. That's a pretty active skyline. Okay, we don't need this music. Okay, awesome. So this is your heat map. Okay, cool. So what I'm gonna do is I'm going to download the file. Nice. I'll open up a piece of software called a slicing tool, and I'll throw this file onto the slicer. We'll slice it. I'll see that it takes way more time than I have today, but I'll go ahead and save this to disk. And then I'll go to my 3D printer over in my basement. Welcome to my house. Little view of, of my house. And I'll throw this 3D printer right here. Nice. Okay, and we'll kick this off. So I really like to tinker and do stuff like this. It takes up way too much of my time. We'll check back on this print later on as the talk progresses, but here's another view of it. Okay, so time to take things seriously. I got everything kind of sorted out. I'm doing a raffle today. If you were interested in getting into this raffle, I know Sonam and AI Camp is doing a raffle as well, but we're doing a raffle for, I took your advice, we're doing a raffle for Star Wars today. And this is gonna be really exciting. So get in here and we'll do this right at the end of my talk. Hopefully I'll have enough time. I'm gonna start speeding up now. If you get bored of me, you can look down there. Okay, I'm gonna go move off this in 3, 2. I'll wait for John. No worries. Okay, thank you. Let's do it. So Weaviate, we're a vector database, and what we allowed you to do is semantic search. Just realized one of my notes is not here. Go to back here. Okay, so we do vector search, and I'm really excited to show some of our search capabilities today, as well as 2 of our newish features. And the 2 newish features that I'm going to show off are multi-tenancy and named vectors, which allow you to store multiple vector embeddings per object schema. And you see, Weaviate has the ability to do semantic search through a technique that relies on HNSW. And we create a large index of all the data that you have and load it in memory so that we can do insanely fast vector search across all of your data. And because your embeddings store semantic meaning, we can leverage the idea of vector search to pull out semantically related information. And so I had this idea that I wanted to build out a project that allowed people around me to get connected and network with others who have similarities or interests or maybe even overlaps in knowledge that allow them to connect and share the knowledge that they have. And so I got this idea on Saturday morning, just after I chatted with Sonam last week, and I decided to throw out all the information I had and all the prep work I had done for this talk and restart. And so that's where this talk comes from. The idea is called Vector Friends. And the idea of Vector Friends is that we ask a series of questions. And these are questions like, for this talk anyways, the questions are like, what's your preferred tech stack? What is your most interested, what are some things you're interested in learning? And actually, why don't we just go there? And what is your favorite open source project and what does it do? So we built out this form and it basically will allow you to fill in information about yourself. It will generate vector embeddings for each of these questions down here. So what is your favorite technology stack? What are some technologies you really want to learn about? And what is your favorite open source project? It creates vector embeddings for each of these, stores them in Weaviate, and then allows you to do named vector search across the different vectors. So for example, what this allows is if someone says, I'm really comfortable with Django backend and maybe they're into like data science tools like PyTorch and NumPy, training my own models, and they're verbose about those things. And someone else says, I'm really interested in learning about data science and the tools involved, then the vector search here will find similarities between those 2 types of input and actually go and produce a response for it. Produce the 2 in a vector search lookup. And so this was the thesis, and this is what I set out to build on Saturday morning. So Weaviate's like core capabilities is actually enhancing in applications like search tooling. A lot of our customers actually already have good search tooling in their tool set or their applications. And so what we find a lot of our customers coming to us for is we have a good baseline for what our search tooling is doing, but we want better search. We want the ability to do like AI-powered search that leverages semantic meaning behind the vector embeddings that we can create. And so with this, we allow developers to take advantage of Best Match 25 for keyword search or vector search that relies entirely on vector embeddings. But also we found developers are trying to go further than this. Maybe they want to have some of the benefits from keyword search. Others want some of the benefits from vector search. And so we created an offering called hybrid search, where you can create a weighted combo of the data that you're looking for and be able to generate responses in a very document search-like way. And then you can tune what your search results look like based on whether you want it to be more vector focused or weighed towards more keyword search results. For this project, I'm just using vector search, but the API is super easy to work with, and we can easily leverage hybrid search if we wanted to. Okay, so let me go ahead here. I'm going to walk through a little bit about this flow. I have to go back to my slides. So we have our form, which you just saw. We take the user input and we pass it into Weaviate through the integrated vectorizer. Within Weaviate, you can actually define the schema and control which vectorizer you want to use, whether that's the like OpenAI vectorizer, a local vectorizer that you're running by yourself in your own infrastructure, or anything of your choice. We have integrations into Gemini, Gemini vector embeddings, AWS Bedrock, the whole gamut. But we basically use Weaviate to generate the embeddings through our integrated vectorizer module that's controlled on the schema, and I can show you what that looks like. And then from there, when we got all the data in there, we basically pull out the data, we do a vector search through some logic that looks like this. This is hard to read, I admit. So let's see. This works. So at a high level, we are going in and retrieving the profiles collection. The profiles collection are basically all the inputs from the form. And I pass in a tenant field or dot with tenant that allows me to say, this is the tenant that I'm going to use for all the people at some particular talk. So in this case, I have GitHub AI Camp talk. I iterate through all of the profiles once we have retrieved them from the vector database. And at that point, I start doing these near text vector searches where I do cross references from one another. So I'll say, find me like the question related to open source and target the vector that's related to learning technology. Or in this case, target using the tech stack of your preference, find the vectors where there are people who are responding with the most interested technology they want to learn about, and find those two vectors and match them together. So this allows us to do like pretty interesting search over different objects within your schema, and it gives you a lot of flexibility and control as to what you can search for and fine-tune the results that you have. And then afterwards, we send an email to connect the parties. From here, we use resend to send emails. And also, do I have this? I don't. I'm using Llama 3 running on my laptop to generate the email contents and to send those to the people. So let's take a look at what this looks like with some synthetic data. All right, so look over here. Let's go pull up this tool over here and just look at these test files. So let's go and test generate a profile. And this is going to generate a series of responses. So I have a prompt here. Only respond with valid JSON. Don't include anything outside of the JSON. Here's an example of the JSON I want you to generate. And the technology stack question, insert an interesting technology stack, be random. Come up with interesting technology areas to learn about. Could be web-related, AI, Bitcoin, or anything, be verbose. And for the open source, insert a random open source project and explain what it is. You kind of get the gist. We're going to generate a first name and email, and then it'll generate a variety of objects. So we use Llama 3 we will generate this, and let's just take a look at what this looks like. So this is running locally on this machine, and it's just going to generate a single piece of data and store it. I guess it's just going to print it to screen, so it's not going to do anything with it. But let's see. I'm running a screen recording, a 3D print software in the background that I can kill, and Llama running locally here. So let me turn off this thing because we don't really need it and it takes up a good chunk of memory. Thank you for your skyline, by the way. Okay, so here's the object we created. This person's name is Julian Gallagher. They're really interested in Apache Airflow that allows you to do stuff using DEGs. They want to learn tools related to natural language processing using Spacey and other modern NLP understanding tools. And in terms of the tech stack that they're comfortable with, they use a Python-based web application utilizing Flask as the microformer paired with React for its JavaScript. And then they use SQL Alchemy for ORM, object relational mapping. Pretty cool, pretty standard. This is kind of what you'd expect from someone who's pretty passionate and inputting information in there. And so what we can do once we have this profile is we can actually go in and insert it into the vector database. So let's take a quick look at this script. Here's the same generation prompt. Here's the same call to Llama. Here, I create a Weaviate client, and I pass in the Weaviate endpoint. I pass in the API key that allows me to connect to this Weaviate endpoint. And then I pass in this header to generate vector embeddings. Now I'm using OpenAI to generate these vector embeddings, and we pass in the API key into the header so that we can actually generate the embeddings on the fly and just send in raw JSON objects and not worry about the embeddings generation ourselves. You have the ability and the flexibility to do so if you'd like. We offer the flexibility for this, but for this particular use case, I just wanted something simple and easy and quick to get started with. So I passed in the OpenAI key here, and I defined the schema in such a way that leverages the OpenAI key to generate these embeddings. So let's take a look at that real quickly. Define schema. Define collection. So this collection has a first name, an email, a tech stack, an open source, and learn tech. These are the 5 fields that we collect in the form. I turn on multi-tenancy, and we use text-to-vec OpenAI across these 3 fields. So by specifying these different named vectors, I can say that this schema will allow you to do vector search across different schemas. This is a new thing for us, and this was actually one of our most highly rated features or requested features on GitHub. And so it's pretty awesome to see that we have brought this to life based on the needs and the requests from our open source community. And it's something that we live and breathe at Weaviate. Okay, so this is the schema definition. Let's actually go and try to generate like 10 of these and then insert data into the database. So I have prepared here a command where I am calling test generate and insert .py. I'm calling this with 5 parallel threads, and we're going to do this for 10 sequences. So we're going to generate 10 objects. If we do this, this is going to take some time because everything's happening here, and we'll actually take some time to do this. In the meantime, what I want to show you is kind of this fairly naive RAG tool where we go in and do the vector search lookups and then pass it into another model to actually identify why these 2 parties might be interested in one another and why they might be like interested in talking. Actually, yeah, right here. So this is test find vector friends and email. What do you think of this? Like, is this something that's interesting for folks? Is like, we come to these events because we want to meet people. We want to find people who have similarities and differences, kind of expand our headspaces. What's everyone's perspective on this kind of thing? Can I get some vibe checks here? I see a nod. I see a couple nods. Would any, like, raise your hand if you would use a tool like this? Like if you go to an event and you want to meet other people. Cool. Anyone here?
It might be even handy in hackathons.
It might be. So that's exactly where I was thinking about taking this next. It's like when you go to a hackathon, you actually have a lot of these skill sets, and you want to find people who have like similar skill sets with you that are overlapping, but not exactly overlapping, so that you can push the boundary of what you and your hackathon teammates are doing together. So that's kind of where I wanted to take this. The people who raised their hand, do you want to try this today? Do you want to try it today? Anyone who raised their hand? Okay, I saw 1, 2. Anyone else here? If we have 6, I'll do it. Okay, not today. So we do this thing where we first iterate through all of the profiles that we've stored. From here, we start doing a vector lookup across our name vector and towards the target vectors. So we say from open source Find Learn Tech, we do this across all the different permutations. So we have 9 different vector searches. And then finally, once we have all of the objects stored, we begin processing the objects. Processing objects is effectively just going in and identifying whether the person creating this object and then appending it to the results array. And if we've already seen this person, so for example, if the person we're analyzing pulled up the same vector search because the text was so similar, i.e. we found the same object in the query, we'll just skip it and move on. And so that's what this logic here is doing. And then finally, if we come down to the end, back to where we called process objects, we print out these lines here and we just iterate through the results and we start sending emails to all of these people. So we use Ollama again to see this. Given the following 2 profiles, create 3 super short prompts to jumpstart their conversation. Don't respond with additional context. Just give the prompts as a valid HTML bulleted unordered list. We pass in profile 1 and profile 2. Make the call to Ollama, and then finally, we go and print the response just so we can see it. As I mentioned, we're using resend to draft out these emails. This is the test email, so it just goes to me. And then it includes these, like the HTML bulleted list here. And then we store them, we just make a note locally and log it so that we don't accidentally lose all of our, like if the script fails, we have a way to look back and see which emails we'd sent. So my parallel process ran and I was able to generate 10 fake profiles. I have a tool here called list all profiles. And I'm going to change this to the test tenant. And now let's run it. And this is just going to list through, actually, let's go and pull it up, list all profiles. We again use the iterator. I found this built-in module in Python. I didn't know about it before. Pretty printer for Python allows us to generate some nicer looking JSON objects. So these are all the objects that we pulled out and we had generated. They're all stored in the vector database. They all have their own Weaviate UUID, and they are all storing different profiles of people based on who is generated from Llama 3. Okay, now what I want to do is, to close up this talk, is actually show off what test, find, vector friends, and email. So find. Cool. And this is just going to go through the logic that I had talked about earlier. So we found 2 profiles, and the first one is to John Doe. It'll go to me because this is just the test file. And so we have Johnny Pone named Caden, and John Doe is the other email. The 2 profiles, one person is interested in learning machine learning with TensorFlow and Keras for predicting stock market trends using historical data. Pretty interesting. This other person, Caden, is, have you ever considered exploring the fascinating realm of natural language processing using TensorFlow 2.7? Of course, it's a very LLM generated text. And finally, we also have our unordered list that we had generated from Llama. This goes through resend, and then finally, it closes up and we should get an email. Let's go back here. So let's see what that looks like. So this is the email. It says, okay, hold on. Yeah, wait, here it goes. So, hey, I'd love to put you 2 in touch. These are the similarities that are found via Weaviate vector search. So how do you think machine learning can be applied to natural language processing? What are some of the most interesting or challenging projects you've worked on in your experience using TensorFlow or Keras? And have you ever used Apache Airflow for automating tasks, and what kind of workflows have you created within it? So that's kind of the high level idea, and that's what we use. That's what this project is using and leveraging for Weaviate vector search to find and connect these fake humans or these fake LM generated profiles. Okay, so that's at a high level what this does. Okay, we're gonna skip this. So just kind of to close, Weaviate's been doing this since 2016. The founders started working on like vectors well before vector databases and vectors became like really prolific in the space. By 2019, we found that companies actually needed a way to store vectors. And so the company was born in Amsterdam. And we've been building out Weaviate as an open source AI native vector database since this time. So we predate ChatGPT. We predated, I guess the original Git repo predates the original attention is all you need white paper. And so like when ChatGPT blew up, so did all of the hype around AI, and the need to store vector embeddings became increasingly common. And so that's one of the huge things that we do. And there's tons of use cases for us, both within enterprises and small businesses, from building product recommendations to using us for like e-commerce search and doing multimodal search. I'm going to show one more thing here. So one of our customers called Moonsift, they use Weaviate to do multimodal search, where you're looking, like say some person is looking for like a specific skirt with a pattern of ocean waves. These are what Moonsift results are pulling up with Weaviate. And here is what like the Google results will show. So across like the way that our customers are implementing this is really interesting, and it's super exciting to see developers kind of get engaged and use these in different ways. I'd love to get connected. If you want to connect with me on Twitter and LinkedIn, these are some QR codes that you can scan. And we've got some upcoming events. So is anyone familiar with DSPy? Cool. DSPy is a new way to interact with vector databases and generating and using prompts with language models, or it's a new way to interact with language models that doesn't rely on clever prompting techniques to get the best results. We have a meetup with DSPy later this, I guess it's the first day of May. And we're co-hosting this with Cohere and Arise as well as DSPy. And this is going to be a pretty incredible event. I'm really excited. We have one of the co-authors, if not both authors of DSPy coming to this. And it's just going to be a super cool way to get like a first person's perspective of like what they see as some of the common challenges within the problem space that they're solving. This one I already talked about. If you want to get in on it, definitely I'll accept you later today. And if you want to get started with a free trial, you can do this. Okay, I guess we have a couple things to wrap things up. So 3D print, we have 2% of the print is done. If you find me on May 14th here back at GitHub, I'll give this to you. I'm pretty sure it'll be done by then. And let's look at the other view. That's the other view. So it looks like it's pretty good. Nice first layer. And I'll close up with the raffle, because this raffle is, I guess, the thing that's on everyone's mind. So how do I do this? Actually, am I out of time?
You have 5 more minutes.
Okay, I will do this on stage right now.
Or you can do it when I run the raffle as well. Up to you.
I'm good either way. If we do it all at the end.
We can do the questions now and then.
Yeah, okay, let's do that then. Cool, so that's my presentation. Thank you, everyone. And I hope you enjoyed this interesting use case of Weaviate vector search to apply for like friend lookups, personality lookups, or interesting topic lookups to find people who are similar to you. And if you want to try it, let me know. I'm always interested in improving this talk and also improving the project here. We've got some interesting ideas that I'm exploring with Neo4j right now on how to build this a little further. But yeah, thank you very much. I hope you enjoy this. Any questions?
Kind of a random idea that came to me when you were sharing your friend's search. Do you think that there's an avenue where this vector search is going to, I guess, somewhat displace general recommendation or predictive models? Because, you know, for some of these things or the use case that you showed with like people searching for dresses and stuff like that, you can build the recommendation engine, but also you can use this vector search. So what's your thoughts on that?
Yeah, I don't think traditional recommendation engines are going away yet anyways. I think that there is a lot of space, like a lot of room to improve in the vector search space. General recommendations is still like, it is a common use case that we're seeing already. It is a lot faster to use a vector database. So like if you're starting a new product or a new company, chances are you won't want to put in all the engineering time to go build out like a full-on recommendation engine out of the gate, but you might rely on something like a vector database to get you started and to get you there to like bringing your true value proposition of your product to market faster. So potentially it might stick, but at the moment, I think it's still like early days to tell.
I guess maybe an additional question on your use case or demo. Have you thought about the idea of hybrid search in cases where, so you have like, I don't know, 5 fields that people have to fill?
Yep.
But have you thought about, let's say, what happens if a person only feels like 2 or 3 and not the others? Do you still, you know, get the recommendations or what?
This is where I put form validation and say you must fill in the form. But good question. Yeah, form validation is my response. Cool. Any other questions? Oh, right over here.
Yeah, I was just kind of thinking about the use case, and considering that like most embedding models or like all embedding models are trained to project embeddings in a similar space, as opposed to like this use case where you might want complementary, embeddings that necessarily aren't so similar. Do you feel that there's an avenue for the research in that regard? And is that something that you guys have thought about?
Sorry, can you say your question again?
So like generally vector embeddings are trained to project, text to similar spaces. But in the case where, let's say you have different engineers who would be complementary, who don't have similar skills, but would be projected into a similar space, based on some other means, considering that the models aren't capturing that now, do you see that like as a potential vein of research or something that you guys can build on?
Definitely, yeah. So I was alluding to like other areas that I was exploring with Neo4j around this. And one of the things is you can actually map out like, so let's say we use a language model to explain in shorter words or more concise terms, or maybe even like split sentences about what the person is describing. We can create like rough outlines or concept ideas of each thing, and then create a graph structure of the ontology of where things are related to one another, and use the graph database to explore like connectedness. I definitely think that there is more research that can be done in the area and how you can drive better results, but I think that can also be done on the application layer of the tools that exist today.
Gotcha. So you don't feel like you potentially would be missing good pairs by like not considering, by like, currently you're just taking a cosine similarity, right? And you're saying this is the highest one.
Yeah.
You could potentially have cases where that cosine similarity is low, but they're, complementary in a sense, if that makes sense.
Yeah, no, definitely. I think this is something that the way this is set up right now will not catch complementary skill sets. Like if someone says they're a really good backend engineer and someone says they're a really good front-end engineer, they might not get matched as a result.
Right.
So yeah, I definitely think that there are ways that you can prompt a model to identify where there could be close matches, like leverage the language model all the way down to say like, what are complementary skill sets and why might these two connect? At the moment, this is not set up to do that, but I definitely think it will miss this situation. It's a good question.
Cool. We have time for one more question, if you have. All right. Last question.
I think more than a question, it's just a thought to share. I think what would be great is, of course, you can use it for your upcoming hackathon, but also probably share profiles that the tool has found, and people can browse through it and say, yes, this is a good pair or a match, and then initiate emails. Something as a pro step within that process.
Yeah, I like it. Not for this upcoming hack night, but it is actually something I'm thinking about. These hack nights are a little too short to create like hackathon teams and create a full-blown project. I've been exploring different ways to get to larger event formats and bring out like weekend events or even like full week events that don't require people to be on site for the entire hackathon, but will like go back to their regular day job. And in the evening, if they're inspired to do something with the new technology that they saw at the hackathon, then to do that. I was thinking absolutely to use a tool like this to find pairs like this and send an email based on those interests. Yeah, thanks.
All right, thank you, Adam, again for this excellent presentation.
Hamza. Cool, thank you, everyone.
And our next speaker is Christy from Zilliz. Please welcome her. Thank you.
I want to do it with some, yeah.
Okay. I don't know where my microphone is, but it sounds like I'm being picked up.
On your laptop.
Great. Yeah, so I was a last minute ad. The speaker, one of the speakers got sick. So this morning I agreed, got an email from AI Camp. Would you speak tonight? And I was like, oh, shoot. Okay. So bear with me. I've got a pretty rough presentation. Nice to see some familiar faces. I also organized an event here called Unstructured Data. So some of you might know me from that. The next one, speaking of Llama 3, it's going to be May 21st. And we're going to have a meta speaker here talking about some of the challenges that they had bringing that model to open source. And I have to say, I am loving it. So I'll also use it in my demo tonight. So obligatory slides about Zilliz, founded in 2017, headquartered in Redwood Shores, vector database, following on the footsteps of Weaviate. I show this one because I get this picture a lot. There's open source vector databases and there's closed source vector databases, and we are both. So we have Milvus as the open source Linux Foundation vector database, and then we have Zilliz, which is our managed cloud. And sometimes in my demo, I use both. So the nice thing is you can write your code in Python, and if you leave off the index, it'll use an auto index, and that auto index will automatically be selected to be HNSW, for example, if it's open source, or something more, a more proprietary, faster auto index if you're using Zilliz. So outline, generally, I'm going to try to get through all these things. This is probably boring for most of you. What is a hallucination? It's because we're in the generative AI world. And when we ask a question, for example, of Gemini, I asked the 3 politicians born in New York City. The first response is Hillary Clinton. If you double check Wikipedia, you know she was born in Chicago. So hallucination. And, just the reason they hallucinate is because of the way these foundational models are trained on token sequences of words. And so if you were to, based on the training data, you ask a question like, the chicken walked across, probably it's the road, but there's a lot of junk in that training data. which is where hallucinations come from. Also, the embeddings come from the transformer models. So the embeddings, there's the encoder part and the decoder part. When we talk about the embeddings, those are these encoder models. They come from the next to last layer, hidden layer of the weights. So basically you can think of that encoder as just like an f of x, and the x is your input and the f is a vector of numbers. And then the decoder is the GPTs and all the LLMs. And so these days, instead of using full transformers, people have learned, oh, it's just much shorter to use either the encoder if you're embedding something, or the decoder if you're asking questions and wanting generated answers. Okay, basically a vector is, it's a vector in space and it's got numbers. And the idea when people say dense vectors, these vectors should be close in their vector space. So just naturally, when you search approximate nearest neighbors in this vector space, the vectors that are semantically close should be the closest. And you've also heard probably a lot about RAG. High level RAG is where you take your data, you pass it through one of those embedding models, the encoder, you f of x it and turn it into a bunch of vectors, and then you store those into a vector database. At first, I was trying to keep them around without a vector database in memory, but you can do that too. Then you have a question, you need to embed that question with the same embedding model. And then now you do an approximate neighbor search between the vectors of your question and the vectors that are stored in your knowledge base. And what comes out is called the retrieved context. Now you stuff that context with your question into the prompt to GPT or something, and you get your answer out. And it should be more reliable and better because it's based on your knowledge, which is quite different a lot of times than just general knowledge. Okay, so I'm going to kind of go through just like the basics of RAG. RAG is still something that there still needs to be a lot of improvements, especially on the retrieval part. As you'll see, for example, how do you choose an embedding model? One place to get started is you go to this Hugging Face MTub leaderboard. You sort it descending by retrieval, and then you get a list of ever-changing models. Now, one of the things that has emerged in the last year is because this particular leaderboard's data is public, people are overfitting their models. And anybody who has this background in data science knows overfit models are bad news because they may look good on a leaderboard like this, but then you try them on your data and you're not going to get possibly good results because your data isn't exactly the training data. So word of warning here, MTub has become corrupted. It's still a good place to just get a good idea of embedding models. We at Zilliz and Milvus, we will vet these for you, so we only support the ones that they're not overfit. And I can eyeball and see some that are overfit that we didn't choose. Okay, another thing with embedding models that we've learned in the last year is, I think if you came to my unstructured data event where Yuri Malkov spoke from OpenAI, he talked about these things called Matryoshka embeddings, where they've learned that smaller embeddings can actually have just as good accuracy. So for example, in the latest release of the OpenAI embeddings, text embedding 3, they have 3 small and 3 large, and those come in different dimensions. So for example, you can have either a 512 dimension or a 1536 dimension. And the MTab score on the 512 is 62, basically the same between having a super long 1536 embedding or a 512 embedding. And this is really important because if you're using a smaller embedding, it means your latency is faster, you're using less memory. Yeah, you can chat faster. So this is yeah, just want to point that out. The other thing that happens when you're doing RAG is you need to, besides choosing that embedding model, you need to think about how to index your data. And indexing in vector databases is, if you took a computer science class and you learned about structures like hash tables, tree structures, bubble sorts, whatever, basically what it's doing is it's taking all of this data and putting it into an efficient structure for search, for that nearest neighbor search that has to happen. And this is our docs page, index.md. And you can see that we support, we'll list so many different kinds of indexes that are supported for different scenarios. So it's kind of overwhelming possibly to choose which vector index to choose from. We have some advice. HNSW is a pretty good place to start. It's yeah, pretty fast. It uses quite a bit of memory, but not as much as IVF flat, which is exhaustive. The other pain point you're going to have to decide when you're doing RAG is how to chunk your data. So you put in a document, and there's this paper that I should have gotten here, but it's called Lost in the Middle. And it shows that, research shows that the longer your document, the less likely, or the harder it is to find good accuracy from that document. So there's a chart where they show the length of the document on the x-axis and the accuracy on the y. And the longer that document gets, the less accurate, because you've got a couple things going on. You've got the lost in the middle thing where it's just too big to get very good matches. And the other thing is that they're learning that these models are, they have like, so another one of my unstructured data events, one of the invited speakers was from LangChain, Lance Martin, and he showed his research that showed not only do you have a lost in the middle effect of long context links being less accurate, you also have, it's called needle in a haystack, where the first and the end of that context are most easily matched, and then the middle kind of is not matched. So this kind of feeds into the fact why chunking is still kind of an art of your RAG application, deciding how to chunk. So kind of like you need to think about what kind of data do you have? Is it conversational data? I'm going to use for my demo today just our technical docs data that Markdown, and then, or maybe you have Q&A data. So chunking kind of depends on that partly. So for example, you know, you would definitely add conversational memory to conversations, you QA pair formatting on Q&A data. For mine, I'm going to use HTML parsing. So the idea here is if you just did chunks, like maybe you have a document that's about, like, you know, it's a car document and you've got the car description for the year 2018, you got the car description for the year 2023. If you just add the titles, the HTML headers, for example, you get a lot more context, and those headers are pretty short. So this is the whole idea behind this thing called in Llama Index hierarchical node parser or auto merging retriever. And LangChain is called HTML header text splitter with the parent document retriever. So yeah, this is like just a glimpse of what goes on behind chunking. So this is what I'm going to demo today. Is I'm going to demo a naive chunking using the recursive text splitter, and then I'll do this HTML headers inserted in the chunks for more context. Yeah, so basically I'm not, okay, yeah, I don't need to go over that. Another thing is the keyword or semantic search, and this is referred to in vector databases as hybrid search. So you can do Splade or BM25 to search for the best matching keyword. This is what we're used to in the past. Semantic search is the dense vector. So they refer to the keyword vector as the sparse vector because it's mostly zeros. It's only got ones where the document matches that keyword. And the dense vectors are the outputs of those encoders embedding models. So you've got two different kinds of vectors. And when you merge the two, it's called re-ranking. and the result is called a hybrid search. Oops, I meant to mention. Yeah, so one of, I guess I also played around with this in the code that I'm going to show you. So BERT was the early model. The re-rankers are considered three types. They're either early interactions, late interactions, or zero interactions. So the cosine, the actual dense vector nearest neighbor cosine search that we do, that's called a zero interaction a re-ranker. If you do BERT, it's considered an early interaction because that embedding model that calculates the relationship between the question and the doc. Colbert is all the rage. It's like one of the most cited papers in the last year. I should have put a link. I'll put a link to the paper. It's called late interaction. It's faster because the relationships are calculated after the embeddings are calculated. So you've got two embeddings, the sparse and the dense, and then you combine them with Colbert, which is calculated offline, which is faster than the cross encoder, which was a pain before. But the thing to notice here is, according to the documentation, even with the Colbert re-ranker, you're only going to get about a 2% increased accuracy. So we're not talking about a lot here, even though it's quite the, it seems to be quite the rage to talk about. Yeah, so I'm looking here. It's probably way too tiny. Yeah, so you see that those dark numbers, even in the research paper, they're just not much bigger than all the other numbers. And this is the Colbert V2. All right, I don't know if there's anything else I should mention. Yeah, I'm gonna try, oh, this is why I love, this is why I'm in love right now with Llama 3. It's a free, so accessing your data is free with a vector database, and so is Llama 3 for the generative AI part, and I really like that for demos. You can see here, oh, sorry, I didn't print I printed Claude 3, Haiku, and Sonnet, and Opus. Okay, I need to update this. So one of the leaderboards that people do still trust is this chat LMSys leaderboard, and it is also changing all the time. So just check it out. Llama 3 is now on there. I need to update this picture. Okay, so now just a quick look at code. Okay. Probably not going to be able to talk about all of this code in about 15 minutes. Let me just go through it. Libraries. I've downloaded all of the docs, all of our milvus.io/docs. I just downloaded them into a local directory so that all I have to do is just a directory loader to load them into docs. So it loads 22 HTML files for my docs. Now I'm going to start up Milvus standalone in a Docker. I could also alternatively here connect to a free tier cluster. But I went ahead and connected. So you'll see here that it's, yeah, the latest release. Now I'm going to load an embedding model checkpoint. In this case, just because it's brand new, I'm going to try something called the, it's called the, what is it called? M3 something. BGE M3, because it does the sparse embeddings, the dense embeddings, and the Colbert re-ranker all at once. And we also decided to support it with Milvus and Zilliz out of the box. So it's a built-in for us. So I just need to import that. And you can see that it's got three vectors. It's got the dense vector, which is 1024 dimensions. It's got a sparse vector, which is really big, but it's mostly zeros. And then it's got the Colbert embedding vector, which can be stored. We don't really recommend it because there's not much value add to storing that. And it's going to add a whole bunch of extra space. Okay, now I'm going to create this collection. So collections and vector databases are like tables. I'm going to call it Milvus docs. And in this case, because I'm using the new sparse vectors, I have to declare them specifically that I've got two vectors, a sparse vector and a dense vector. And I'm going to use the HNSW index here with some parameters. So this is another part of the RAG where you can probably tune those hyperparameters to find the best settings for your index. Okay, so I dropped and created it so it's fresh. Okay, so the first thing I do is I can do a simple chunking, which basically I just take like a chunk size 512, I take a 10% overlap, and I go through and I loop through and I recursively split my text with a 10% overlap, fix the URLs. And in this case, I see that I took my original 22 documents and now there are 362 chunks. And I want to double check to make sure, yeah, I parsed that correctly. Okay, the second kind of parser is this HTML parser, which I mentioned, where I keep the headers and titles as part of the semantic knowledge inside the chunk. And it's not much different. You just need to decide which HTML headers you want to keep. Yeah, and then it's a little bit different. So I can see that the number of chunks was 304 in this case, so it's slightly different chunking strategy. Right, just make sure I've got my URLs correct. Okay, the next thing you need to do is embed those chunks. So now you've taken your big input data, you've chunked it into little pieces of text. And the similar concept for images, you probably chunk your images too, and then embed the images. So in this case, this is probably the longest running step. I wrote a blog last week where I used Ray data, and Ray data from Anyscale, from the open source Ray project is actually pretty useful for this. I think something's going to happen where you can do this embedding step in parallel, which makes a lot of sense because the chunks don't need to have statefulness between the chunks that are being embedded. You can just like distribute those chunk embedding tasks. Which really speeds up. In my case, when I did like 50,000 chunk embeddings, regular pandas, because I have a wimpy laptop, I only have 16 gigs. It was like hanging and taking 4 hours. I didn't even wait 4 hours for it to finish. And then I did it in Ray data in like 4 minutes. So it's definitely something I'd say for a practitioner to think about there, that chunking step. Okay, now I'm going to insert that data into Milvus. And then, I create my chunk list and then I insert it. Okay, so I inserted all those entries, and people asked me for this, so I just added it to this notebook about API calls. If you want to see like how many entries you have or some info about your collection, those are typical API calls. You can see that there's 304 rows, and you can see all kinds of stuff about your collection. Okay, so now we get to the final part, the generation part. We're going to ask a question. I'm going to ask some questions about Milvus, like what do the parameters for HNSW mean, for example. And then do the vector search. So vector search is pretty simple. All I need to do is say how many top K do I want to do approximate zero saver search. I'll add this at some point to my demo, because what I can do is I can plot all the distances, and the distribution of distances is going to be different for every single data set. It's not always the same. And so the top K will vary depending on what your particular distribution looks like. Mine tends to be like 1 or 2, and then the distances really drop off in the way they're distributed. Okay. I'm going to go ahead and with those together so I can look at them. And I'm not going to run this here, but I set my top K to 10, for example, and then I just printed out what my Colbert embeddings were before and after. So in this little step here, I've got, you can use a re-ranker or you can not use the re-ranker. And so I just plotted out for myself. I was curious what if I said re-rank true versus if I said re-rank false. And I only saw a difference in like the 7th through 10th vectors that were retrieved, which to me kind of like jives with the idea that re-ranking sounds cool, but it's like really small, negligible. Probably you're not going to see much difference. But anyways, I turned re-ranking on because it's a late interaction, so it's fast. But for me, it's not going to make any difference, I know. All right, so then I'm going to choose an LLM to chat. And in this case, just because it's so much fun to try these, I tried the Llama 3 using Ollama. And then I also tried the Claude 3, which 2 weeks ago was the last week. Maybe it's just 3 weeks ago, Claude 3 was hot news. Because now it's Llama 3 is hot news. And then the GPT 3.5 Turbo from OpenAI. So what I do here is I just jumble my context together and my sources, and really recommend trying this out, this Ollama. It's like magic. What they've done is there's a special term for it, not the GGML, but the GGUF, which is they've converted these things to run on CPUs. And then they've also added all these quantizations. Quantizations is like a compression of a vector. And so this can run on a CPU, even a wimpy CPU like I have. Mine is super wimpy. So just it took Ollama I think like a few days, and they ported the Llama 3 into Ollama, and then Ollama you can run on your laptop. And if I print this out, for example, I just import Ollama. I say that I want to look at the model that I've pulled from the Ollama. I pulled a Llama 3, and it'll tell me that here's the format, it's the 8 billion, and here's the quantization Q4. And then I was curious, in case you're curious, there's you can go to Hugging Face and see what all of these different quantization methods mean. So Q4 is the smallest quantization method, and they're kind of smart at figuring out what kind of laptop you have, what kind of quantization you're going to have when you download it. So yeah, Q8 I guess you shouldn't use, because otherwise why are you trying to do it on your laptop? I mean, you've already got a big computer. So yeah, okay, here's my system prompt. Use the context below to answer the user's question. Be clear, factual, complete, concise. The answer is not in the context, I don't know. Otherwise, answer with fewer than 3 sentences. I don't want a whole bunch of stuff. And cite the grounding source. And yeah, give me the answer, give me the source. So I'm going to ask this question. So this is, yeah, Llama 3 running on my laptop. It's going to have a little bit of latency. Yeah, parameters M, and it gives me the source. But I know that that's actually not a good answer, because there's 3 parameters. I'm not going to run Anthropic right now because it costs money. Okay, so rundown on Anthropic. There's 3 different versions. Haiku is the least expensive. Haiku is even less expensive than GPT 3.5 Turbo. Opus is the most expensive. It is amazingly expensive. I went to a hackathon where I got free credits, and that's where I tried all these out. So I have screen grabs of what they did, and I saved them. But my free credits are gone. So yeah, it was interesting to try that out. I can do. Oops. Let's see. Do I have it? Oops. I tried to save it somewhere. Oh, I saved it here. So here's my prompt. And then you can see that Haiku is the cheapest. It's actually the longest. And then Opus is the most expensive. Sonnet is in between. You can see how much they cost. Like GPT 3.5 Turbo, 50 cents for the input token, 150 for the output. Haiku is 25. So basically like half the cost for the inputs, 125 for the outputs. But Opus is like $15 and 75. So like, okay, but yeah. All right, and then last, I'm gonna use OpenAI. So here I'm using the 3.5 Turbo. I can specify the temperature and a random seed. I like this random seed thing because then I'm always gonna get the same answer. And this is actually a really good answer. There's 3 parameters: M, max degree of the node, EF construction during the index building, and EF used during search. So yeah, just in like, I think I have a couple minutes. So I'm gonna venture into the world of evaluating RAG. I have learned that I like this little open source package called Ragus. Well, probably Ragus is probably how you say it. Ragus. They were also speakers at one of my unstructured data events. So the way they view this thing is when you evaluate a RAG pipeline, you evaluate the whole thing, but you also evaluate component-wise. And you can think of it as like a parallelogram. So the components are your question, what's retrieved, the context, the LLM's response, and then the ground truth answer. And they're using this thing that's kind of proven in research these days. It's called LLM as a judge. It came around because Jan Stoika and his graduate students at UC Berkeley did some studies where they found out that humans agree with each other like maybe 70% of the time. And GPT-4 also agreed with humans 70% of the time. Therefore, ergo, a LLM is as good of a judge as a human. So yeah, it's called LLM as a judge concept, and it's just kind of taken the world of labeling and testing by storm, because now you don't need thousands of labeled data points like you used to in the past. Now you can get by with like a handful of labeled data points and use LLM as a judge. So that's what's going on here. LLM as a judge is going to measure between the question and your context, the precision of like all the little pieces of facts, how many of them are in your context. Context, the recall based on the context and your ground truth answer, what was the coverage and preciseness. Between the LLM generated answer and your context, was that generated answer faithful to the context? Between the generated answer and your query, are they relevant to each other? And then finally, the answer between your final answer, RAG output answer, to the ground truth answer, is it correct, is it similar? So there's all these different metrics that you can measure. And I'll just show you really quickly how you do this. So they are built on LangChain, but you hardly see it. But basically any embedding model or any LLM that you can use with LangChain, you can use with Ragus. So you define like all your metrics that you want. You do have to have a ground truth answer data set. In my case, mine's super small, I only have 4, but you don't actually need that many, like maybe a dozen or so to get pretty good answers these days. And basically you need your question, the ground truth, sources for grounding citations. I've got 2 contexts here that I'm gonna measure. First is that simple one, and then the second is my HTML structured context retrieval. And then I'm gonna have 3 different answers: the OpenAI answer, the Llama 3 answer, and the Anthropic answer, the Haiku answer, so the cheap one. Oops. Oops, what did I do? Oops, what did I do? I know my code's there. Oh, shoot. Oops. There's actually code there. I don't know. I don't know. Has anybody seen this before? How come I can't see my code? Oh, there it is. No? Well, okay, sorry about that. So I just basically imported this function where I have assembled the Ragus data set. It's a Hugging Face data set from my pandas data set. And I run this, I kind of pair out whether which column I'm evaluating. And then I do this ragus.evaluate of the metrics that are passed in. So yeah, so this one was measuring the simple chunking, and I get a contextual score of 0.37. And how come I don't see? Darn it. Sorry, did I save it somewhere? Anyways, darn it. Okay, this is what I get for having a brand new demo. My punchline is hidden in this little hidden thing here. My punchline was that I saw a context mean score retrieval score of 0.5 when I used the HTML chunking method. So this is a way that you can like kind of go through your RAG workflows and see what's working and what's not on your data. So in this case, because it's HTML data, I use the HTML header parser. I got an improvement in my of my retrieval score, which is about a 35% improvement. Versus I ran this on every single one of my my LLM outputs, and I got like a 1% improvement. So I think this is another thing that people are learning, is that if you are going to spend time somewhere on your RAG, fine-tuning your RAG pipeline, the retrieval step has the most room for improvement. All right, thanks.